Program flow control in C++ also has something called while loops. While loops allow us to repeat a process in a program as long as a specific condition or set of conditions are true. In other words, as long as something's true, the process will keep repeating. We'll need a condition that is true to enter the while loop, and we'll need one or more exit criteria inside the while loop so the program knows when it can stop completing that particular loop. We'll use something called comparison operators and a new variable type from time to time called bool. Let's start by looking at our old friend the for loop, where we had a fixed number of opportunities to run a certain set of code. In this case, we started at I equals 0, kept going as long as I was less than 8, and used the increment I++ to add 1 to I each time. And then it repeated the code inside the squigglies. If you have any trouble remembering how we use for loops, exit this presentation and go back and review the one for for loops in the program notes. Now we can do the same idea with a while loop. For example, we'll start with an integer called I, make it equal to 0. It can get into the while loop because 0 is less than 8. So on the first time through, I has a value of 0, and the line that says I plus equals 1 adds 1 to I each time it goes through the loop. It only repeats that code which is inside the squiggly brackets. So as you can see, the int I equals 0 looks just like the piece did in the for loop. As long as I is less than 8, that's the second condition in the for loop. And then the I plus equals 1 does the same thing as I++ did in the for loop. Okay. While loops, however, give us even more flexibility than a for loop. For example, in this case, we start out with I equal to 0. While I is less than 8 and I divided by 3 is not equal to 2, the code in between the squiggly brackets will repeat. At the end, we're still incrementing I by 1. So in this case, we start with I equal to 0 so it can get in the while loop because 0 is less than 8 and 0 divided by 3 is not equal to 2. It adds 1 to I each time and has no issues with the while condition until I is equal to 6. When I has been incremented enough times to equal 6, we'll see the second condition where 6 divided by 3 not equals 2 isn't true, because we know that 6 divided by 3 is in fact equal to 2. When that would happen, this program would stop executing the code inside the brackets and continue with the rest of the program. Now we have a number of different symbols we use to compare things. Two equal signs together without a space between them is what we look to see if two values are equal to each other. We could have if A equals B. In other words, we're seeing if the variable A and B have the same value. The exclamation point equal stands for not equal, like we just did in the example before this. Less than, pretty straightforward. Less than or equal to, similar to what we'd use in algebra, but in this case we use the less than sign and the equal right beside it with no space between them. Greater than, very straightforward. Greater than or equal to, working just like less than or equal to. We can also compare, as you saw in our example, more than one condition. When we say and, which is two of the and signs together, you'll find those at shift 7. That means that both conditions must be true for the while loop to continue. And we could actually have a number of conditions. We could have 2, 3, 4, 5, and so on, whatever was necessary to make this work. The OR symbol, two straight up and down lines, which is a shift and the key right above return, allows us to say, hey, only one of the ones indicated have to be true. If this is true, or if that is true, or if something else is true, we could separate each condition and have a number of comparisons. Now, here's yet another way that you'll find we can use a while loop. In this case, let's say we have a variable char, go again, equals, and we have a small y as a character variable indicated inside two single quotes. Our while loop could say while go again is equal to the small y, or go again equals the capital Y, repeat what's inside the squigglies. At the end of that little segment of code, we could say with a cout, if you wish to go again, enter Y for yes and hit return. Then you would have to cin your response. If you were to cin a Y, the program would go again. If you were to cin anything other than a Y, then the program says, wait, you don't meet my while condition anymore. You're no longer equal to a small or a capital Y, so therefore we'll exit. This also shows you in some cases how we could have used the OR idea so that we wouldn't have to worry about whether or not the user was entering a small y or a capital Y. Alright, let's look at another example. In this case, we have a new type of variable called bool. Bool variables can have two values, true or false. In this case, we could say bool go again equals true. Now let's say we have another variable int a equals 7. Notice I go while go again. Since go again is a bool and can only have values for true or false, I wouldn't need to have while go again equals true, because that would be redundant. So for bools, you just put the variable name. If it's true, the loop will work. If it's not true, if it's false, has that value, then in fact it'll just ignore what's in the while loop squiggly brackets. Inside this while loop, we're saying while go again, and since we set go again as true to start, we'll now go in and all we're going to do is say that a is equal to a plus 5. So each time we go through this loop, the old value of a will have an additional 5 added to it until we get a new value. This will repeat as many times as necessary because we have our exit condition saying, hey, if a modulus 7 equals 0, in other words, if when I divide a by 7 I get no remainder, then it'll set the value for go again to false. If that were to happen, the while loop would stop and the program would continue with the code after the while loop. Now, is there a case where this might happen? Well, off the top of your head, you can probably figure out that 77, if divided by 7, would be equal to 11 without a remainder. And sure enough, this program would eventually stop when we keep adding 5 to a and we get a value of 77. So while loops can be used in any number of ways. They're very important in programming because they allow a condition to keep going as long as something is true. Okay, might be a little confusing. Your first example that shows you a go again for a program should allow you to use it several times before you start worrying about some of the finer points on how we do this flow program control. Okay, let's move forward and use this in our programs, the first one of which will be making a program go over and over again until we say stop.